What did you get for me? It's ugly, but I think I got it ugly. They're not all
All right, guys, let's take a look here. There's nothing wrong with asking any question, but some of the questions have me concerned. And it's not necessarily your fault that you're coming in not remembering or not understanding how to do certain things. I don't know where you came from, who your last teacher was, what information they might have cut out. I know there are some colleges that want to have more success rates, so they've made their classes easier than they should. They don't do that shit. So, anyway. So this guy, what do I want to rewrite first? So I am not taking a derivative yet. I'm just rewriting some pieces of this. How do I rewrite this piece? X to this. And this piece would be minus 3x to the negative power just means flip, right? Now I can take a derivative. Okay, 12x cubed. 12x. 6/5, I like it. 3 minus 5 is. And then here, you really can stop there. If you wanted to go further. That's what you're doing. Negative power means flip, so anything with a negative power flips. What happens to this? It's a negative power, so this goes down. Bam. That's all. That's all. That's what a negative power means. And this is an example of something you should really just be a part of you, right? It should be part of your fiber in your being is to do that. Okay. This involves that thing we just talked about, we just learned. But again, the derivative rule I'm using is product rule. So you can always write the rule first, right? Always. In fact, I highly suggest you do that. Because now you can focus a little bit better. What's the derivative of 5 to the x? 5 to the x times secant. ln 5, I like it. What's the derivative of cosecant x?
Cosecant x times cotangent x.
Yeah, one of the most evil little derivatives ever. Secant? Sure. And then one thing you definitely should clean up is just put a minus there. You could also, I mean, if my question was find where this thing has a horizontal tangent, then you would want to factor it, right? Because you want to equal it to 0. But there's nothing you can really do to simplify this, so you can stop. Factoring is not simplify. Factoring is unsimplify. Simplify means do the operations. Factor means undo multiplication. They are opposites. So if you don't factor, that's fine. This one What is cosine 2? It's a number. So what's the derivative of a number? Okay, next. Oh, shit. Oh. Now this one I'm going to do two ways. I told a lot of you guys the shortcut is based on what I wrote up on the board. Now if you don't do the shortcut, when you do this derivative, what's the inside function? Sine x to the 4th. So derivative ln of something is 1 over that something. And then I got to multiply by the derivative of the something, right? 1 over sine x to the 4th. What's the derivative of sine x to the 4th? 4 sine x to the 3rd times?
Cosine x.
Good, derivative of the inside. Just hang on, if you did the shortcut, I'll do that next time. How many sines die? 3 sines die. So you end up with 4 cosine x over sine x. Which is also known as, if you want to, 4 within. Oh, I forgot one, didn't I? Let me do this one a second way on another piece of paper, and then I'll come back up and do this one. So the better way to do this problem, and the better way to do every derivative problem, is to simplify what you can before you do the derivative. It kind of makes sense. Make it simpler before you do the weird shit. So what can I do with this one? I can just take 4 down. So what's the derivative? It would be 4 times 1 over sine x times the derivative of sine, which is cosine. So I still get 4 cosine x over sine x, just a lot quicker and neater. You can still make that 4 cotangent x if you want to. Now again, two things here. So you guys need some review on some things. But secondly, when I do a worksheet like this, I'm not saying you're supposed to be able to do all these perfectly. That's not the point. Make some mistakes. This is a great place to do that because I'm not counting this for a grade. So do something. Don't get defeated if you did it wrong. Pay attention to what went wrong. Why did I think about that wrong? What's the right way to do it? Do I totally not understand something? Oh shit, let me make a note to get somebody to explain that thing to me. Right? Don't just go, well, I'm going to miss that problem on the test. Okay? Alright, let me come back up here and do this one. So at least one person took that up and did it the way I used to do it as a student. But if I do this quotient rule, what's the sum? So the derivative of the top is awesome, times the bottom, minus, leave the top alone, what's the derivative of the bottom? All over what? Again, fight the urge to do this, right? Cannot cancel it 2x plus 3 because there's a minus. You can't do that shit. So what I get? I get 6x e to the x plus 9 e to the x minus 6 e to the x. So I get plus 3 e to the x. Is that alright? Just combining like terms up there. And you can factor the top and all that. If I said find the horizontal tangent lines, then you would definitely want to factor. But here, no. You just stop right here. What's up? Sorry.
Can you
Yes. Yes. Like I said, if I asked you to find the horizontal tangent lines, you must factor the top so you can see where it's 0. Here you don't have to factor. If you do, I'm not going to count it wrong, but factoring is the opposite of simplification. You really don't have to do that. You're done at this point. Now, this one group I apologize to because I thought they were doing it wrong, but they were doing it fine. The one thing you can't do here is what we did here. Why are these different? Yeah, this is natural log of 4 things multiplied. That's got the rule. This is squaring a natural log. So that's not what the rule has anything to do with. That's not what the logarithmic rule has anything to do with. So how do I do this derivative? Is something squared? So it's 2 times something to the first times derivative of that. Right? 2 times this for the first times, the inside gets a turn for a derivative. So this, of course, is going to be, let's just write all this stuff out. 2 ln 2x minus 3. What's the derivative of this piece?
1 over 2x.
1 over 2x minus 3 times derivative of the inside, which is 2. So the derivative of ln is 1 over thing, and then the thing gets a term. So at the end of the day here I get 4 ln 2x minus 3 all over 2x minus 3. So you stop here, or on the edge of losing a point or something, you got to do some simple simplification. If anybody cancels these and says 4 ln, I'll revote them. I don't see that happen. All right. So equation of the tangent line. So I need slope and a point. Check for the point. Now I just got to find the slope. And of course, to find the slope, I take derivative. So what's the derivative here? What's the derivative?
2 tangent.
Yeah, so the 2 comes down, tangent by x, and then tangent by x gets the term, right?
Yeah. That would be c squared by x.
Is that cool? This is tangent by x squared. So you can always rewrite a trig function with a little inside power. You can rewrite it as that thing to the, just to really make it clear what rule you're using. This is just the inside getting a term. So this is 2 tangent by x. What's the derivative of tangent?
Secant squared by x.
Secant squared by x, and then that's inside
Pi.
pi. So I can bring the pi out front, but I don't want to rewrite it all over. So how do I get the slope then from this? Yeah, plug in the d-force. You just pull the pi over here right now. 2 pi tangent of 3 pi over 4 times secant squared of 3 pi over 4. I might say something specific about this on the test, but even if I don't, if there are angles you know, I don't want to see decimals any freaking way. Not those decimals. You know 3 pi over 4. It's a really nice angle. What's tangent 3 pi over 4?
Oh, we just
Negative 1, because you're in the second quadrant, sine and cosine different signs. Negative 1. And what's secant 3 pi over 4? Oh shit, that's going to be 1 over what? 1 over what? What's secant related to? Cosine. What's cosine of 3 pi over 4? Not 1 over 2. Square root of 2 over 2, which remember is the rationalized form of 1 over square root of 2. Why is it better to think that way? Because secant's going to take that and flip it. That's square root of 2. Now, to be honest, cosine of 3 pi over 4 should be, it's in the second quadrant, so cosine's going to be negative. I'm going to square the damn thing anyway, but right here I'm going to put negative rad 2 squared. So what do I get here? I get negative
1 or negative 2.
What's this? 2 times 2.
No,
It's not negative though, right?
It's positive.
So it's negative because of this. That's 2 times, let me write this in. 2 pi times negative 1 times 2. So I get negative 4 pi. And that is the what? Slope. So we're almost there. Yes, I'm asking for the equation of the tangent line. We just got the slope. So now I can do y minus the y piece equals negative 4 pi times x minus the x piece. Right? or you could solve for b, you could use mx plus b and solve for b. Whatever way you do it, have a way to do it. So you're going to get negative 4 pi x plus 3